So good morning to one and all. It's indeed a privilege to welcome you all to this session of our X-Team conference. We are honored by the presence of our distinguished guests, speakers, and participants who have joined us today. Let us look forward to enlightening the session filled with inspiring ideas, meaningful discussions, and valuable takeaway. So today's session's the chairperson, Dr. Balakrishnan Nair, Director Inquiries, and followed by plenary talks given by Dr. Satish Singh, IPG Paris. A quick introduction about Dr. Balakrishnan Nair. Dr. Balakrishnan Nair currently is Director of Inquiries in Hyderabad and the Ministry of Health Science, Government of India. He is one of the founder members of Inquiries with over 25 years of experience in ocean science and is lead the Ocean Information and Forecast Service Group at Inquiries for nearly 2 decades. Dr. Balakrishnan Nair holds PhD in Marine Science from Mangalore University with a CSIR Net Fellowship, and his research interests include operational oceanography, real-time ocean observation systems, wave modeling, and marine biogeochemistry. Under his leadership, Inquiries has established robust real-time multi-parameter ocean observing networks and operational forecasting system delivering daily ocean state, high wave alerts, advisory service to India and Indian Ocean rim countries. Internationally, Dr. Balakrishnan Nair serves on the steering committee of Global Ocean Observing System, GOES, of Intergovernmental Oceanographic Commission, IOC, UNESCO, also Vice Chair of Expert Team on Met-Ocean Requirement of the World Meteorological Organization, and coordinates ship observation team and wave climate programs across the Indian Ocean region. His contribution have been recognized with prestige National Geoscience Award 2014, Ministry of Mines, various awards of e-governance, and a Young Scientist Award 2000. Dr. Balakrishnan Nair has published more than 110 peer-reviewed papers and continues to guide doctoral students in Indian universities. In essence, Dr. Balakrishnan Nair has played a pivotal role in steering India operational oceanography and blue economic service from research-oriented focus to an end-user-driven operational framework linking ocean science to societal application and national maritime studies. So I would like to invite Dr. Balakrishnan Nair come on stage and take over the session.
Welcome all. Today's plenary talk is Andaman-Nicobar Subduction System and Andaman Sea, Natural Hazards to Natural Resources by Dr. Satish Singh, IPG Paris and University Paris, France. So the significance is very important for this Andaman in respect of the ocean, because Andaman is in the subduction zone, and it is actually the region where we can get a near tsunami or local tsunamis. So Government of India is taking this very seriously, and Inquiries is establishing a big observatories and a regional service center for Andaman, including the state-of-the-art cable observatory to observe tsunamis and the earthquakes. So in this aspect, I think it's very important. And that's Andaman is a region where a lot of development activities are going on, and a strategically important area for India. So I feel this is very apt and a relevant subject for this symposium, this seminar series. So let me introduce Professor Singh. Professor Satish Singh is a professor of geophysics at the Institut de Physique du Globe de Paris, renowned for his pioneering work in marine geoscience and theoretical seismology. He holds a key research position in University of Cambridge and several leading global institutions. With over 135 publications, including in Nature and Science, he has supervised more than 50 PhD students and postdoctoral research. Professor Singh's research focus on the lithospheric dynamics, seismic imaging, and earthquake process. So I invite Professor Singh for this plenary talk. Thank you, Professor.
Okay. Thank you very much for invitation, and I'm really pleased to be here. And it is great to see so many familiar faces, friends, and all the gurus and everyone else. So you'll be surprised, this is my first scientific meeting in India. I have attended SPG, but never IGU or any, so I'm very pleased to be talking to you. The work I'll present here is not my core focus. It was a fringe of the science I did because I was on the other side. In Indonesia, we were not allowed to work in India for reasons you know very well. So, however, I managed to do something. So I'm going to present that work. So I have several topics. I talked about Andaman-Nicobar, and since it was blue energy, so I thought that I give a flavor of what could be done, what is possible in Andaman region. Just to kind of start, there is a pointer somewhere? Okay, pointer. Anyway, so if I don't get the pointer, I don't know it is working. You will see that tsunami of 2004 in Banda Aceh, and the top figure is the before the tsunami, and the bottom one is after the tsunami. And that kind of gave me kind of motivation to go and work in Indonesia. I never worked on subduction zones before. On the 27th December, I decided I'm going to work in Indonesia. And on the right side, at the bottom, you will see there was a kind of gas discovery in the east of Andaman by All India. So I've been following that and looking into, and some of the things we published long time ago might enlighten us what we are finding here. The message here is that we are very much focused on applied problem, energy, tsunami, no one looking at the basics. What I had done is the very basics. And you need the basics for the future. Quantum physics we talked about yesterday is not the discovery of today. We need to have the basic research to think of the future. And I have been about 3 months in India this year. Everyone is talking about CO2 sequestration, hydrogen, this and that, all the time, money, money, money. What we need is sit down and do the basic science. And the basic science does not give you results today. It gives the result 20 years down on the road. Unless you prepare for it, you will never succeed. You'll be always scratching the outside of the whole thing. So that's the message I want to get across today. So just to kind of give you what happened in Indonesia, we had 2004 earthquake in here, big one which caused the tsunami around here, and then 2005, 8.7, big one. 2007, 8.4 in this area. And in 2012, 12, yes, big 8.6 magnitude earthquake. 8.2 here. And there was one 2010 earthquake here, 7.9. And you saw earlier this year in Myanmar. Just kind of monitoring is not sufficient. Understanding is that's how we will do. So just to advance what's happening in Andaman region, those who are not expert in the area, You have Indo-Australian plate subducting beneath the Sunda plate, and that when it gets locked for a long time, depending upon how long it is locked, that will give the size of the earthquake. Second thing matter is the area it covers. The larger the area it is locked, bigger the earthquake. And then along as well as down deep. So we need to understand all that if you want to understand what is happening, earthquakes. Second thing is the plate is subducting obliquely. It's not orthogonal. And third thing is that you have a 90s ridge, which I will talk in a minute, impinging in this area. So all this changes the dynamics of the subduction in this area. And most interesting, you have a thick Bengal fan sediments, which are going through, as we'll talk about that, which forms the 4R high. And I will discuss what are the different structures here. You have a lot of highs, we will look into that. And then behind that, you have active strike slip fault, Andaman-Nicobar fault, spreading center further in, and then Andaman transform fault, which is here, which connects with the Sagan fault. And that's the kind of big faults. However, there's a big basin in the east here, which is a very oil-producing, a gas-producing field. We have a part in India, not all of it is rest in Indonesia, but we need to look into that in the context of oil and gas exploration in this area. So what I will do in this talk is summarize my findings, highlight natural hazards, natural resources, which might be relevant to this discussion, and what should be done. I think my message here is not just what I have done, the future. And I'll start from the 90s ridge, which is this one, next slide. So what is 90s ridge? It's a big linear feature, about 6,000 kilometers long, formed at the Kargulan, interaction between Kargulan Plateau and the Wharton Basin spreading center between 120 to 42 million years. And we need to know the history and dynamics of it. As we go north, it is buried beneath Bengal fan sediments, and as I said, subducting obliquely. So we need to see the role of this in the whole context of the geodynamics. Here is some of the images given by Sriram Babu. That is beneath this is the Andaman-Nicobar 90s ridge. What you are seeing here, this is the subduction zone, this is Andamans, and this is India on this side. You have several kilometers of thick sediments of the Bengal fan sediments. On this side of the 90s is Nicobar sediments. These two fans were separated about 9 million years ago. So on this side, Nicobar, and this side. You have already the volcanic ridge, which is the volcanic origin. The most interesting discovery we made in 2014 or 15, presence of thick old sediments, which are not the Bengal fan sediments. We do not know the origin of them. We interpreted that time that they are linked to some continental origin, but we had no idea. And if these sediments are formed before 30 to 40 million years ago, 90s ridge was far away, so it could not have been recently. It has to be older. If it is older, you might have some oil and gas in that area. The main conclusion was that these sediments are linked to, or 90s ridge in this area has a continental affinity. So what is the implication for this? Because if you are looking at the earthquakes, you have to see what happens. This is the seismic image we published in 2014, I think. This is the seafloor. This is your Nicobar fan sediments. This is your subduction front. And these are the sediments, older sediments, which are subducting. So the Bengal fan sediments are accreted, and I'll discuss that in a minute. But the old sediments are subducting. What it means? Sediments are hard, flat, and they basically create a flat surface interface between the upper plate, which is subducting, down plate subducting other one. So if it is a large surface area locked, it could produce large earthquakes. So that's the message I want to. Second thing is that these sediments are lighter than oceanic crust. So they will not subduct, they will go up, resist because of natural buoyancy. So when you are thinking about earthquake processes, you need to understand the basics of that. So the question you'll be asking, will there be a tsunami in this area? Of course, 2004 earthquake said that there was tsunami. But what we found over the last few years, that 2004 Sumatra earthquake and 2011 Japan earthquakes, they are very large. They produce large tsunami, which you can say that's perfectly normal. However, 2005 Nias earthquake and 2007 Mantawi earthquake, they were large, 8.5, 8.7, no tsunami. Can anyone tell me why? I will tell you if you ask me later, but I'm focusing on something else. 2006 Java, 2010 Pagai earthquakes, they were small, 7.8. They produced 16-meter large tsunami in the area. Thousands of people died. The question is that do we need a big earthquake to produce tsunami or something else? And this is what I'm going to discuss. So what we found that to produce tsunami, you don't need large earthquakes. You need the large rupture propagating to the subduction front. That's what happens in 2004 and 2011. We published a paper a few years ago about the Sumatra earthquake. What we discovered recently, which is the key purpose here I'll discuss, the pop-up structure. What you are seeing here is this is the downgoing plate, and this is the accreted sediments. You will see that instead of having one big thrust, you have several small pop-up structures, we call it. And we believe, and we published a paper a couple of years ago, suggesting that these pop-up structures are the main cause of the tsunami, even for small earthquakes. Okay? So the question we'll be asking in Andaman region, do we have these features? Obviously, we have one line. This one, I got this data from PGS, so we published this. That's all I have. We have no idea how these structures extend along the whole margin. So a few more words about pop-up structures. How do they produce tsunami? Normally, the plate moves in this direction, and these are the small pop-up structures. We have marked that way. So when a big earthquake occurs, that structures uplifts small, and that uplifts the water and create large localized tsunami. So that's the basic concept. So for example, in this figure, we have a slip of about 10 meters here, and that could produce a vertical uplift of 10 meters on the pop-up structures. If I uplift 2, 3 pop-up structures, I can have a very large tsunami, localized one. In Andaman, localized one is a bad news, or anywhere else along the coast. So basically, the pop-up structures are the main cause, and our objectives should be to map these structures laterally where they are in Andaman region. And that's where you will see tsunami will be generated. So what about 4 arc high? Again, do we know much about it? I remember reading papers suggesting that you have a 95 to 100 million years old ophiolites. Is it continental, volcanic, or it is accreted sediments? I would like to ask the audience, can someone tell me what it is? As of today, we do not know much. And so I would like to focus on that at some point. So that's the question. One thing I discovered a couple of years ago, I mean, a long time ago, there's a big, large, oval-shaped basin here, which is on the 4 arc high, things goes up, this goes down. This is not a 4 arc basin. What it is? We interpreted that at times due to the subduction of fracture zone, but we need to look at what's happening. And that also controls the earthquake size processes. What happens as you go further east of Andaman Islands? There are several faults, which is the eastern margin fault, and what is the name of the fault? Diligent fault. Before I came in the picture, Diligent fault was a strike slip fault. As you will see here, it is not a strike slip fault, it is a back thrust. So you have a thrust going on towards the subduction front, and you have a big thrust in the back of it on the east side. And that's also active. We predicted for the 2004 earthquake, during the earthquake, back thrust also ruptured. So if back thrust ruptures, you will produce localized earthquakes and tsunamis. So that's other dangerous stuff. Other thing we noticed at that time, that you have forearc sediments, basin sediments, but you have older sediments. Those old sediments cannot be formed in the current environment. So they must have been formed before the whole Andaman Sea opened. We propose that this lower part is the part of the Malay Peninsula, which was attached to Malaysia, and now it is part of India. So if you really want to be, you can claim that Malaysia is part of India. And obviously, India has spent a lot of time on gas-hydrate in the north. Here, I see a lot more gas-hydrate in the southern part of the area, and this is other. So basically, the message is that where this discovery comes from, either because of these gas-hydrate type structures or the continental margin sediments. Again, you need to drill, you need to study, and then you can say what might be happening. So as you go further east, it gets equally exciting. As the plate is subducting obliquely, the thrust component is normal to the subduction zone, and then there's a strike slip fault. And the Andaman-Nicobar fault is a part of that system, which starts near Java-Sumatra border as the Sumatra faults and goes far up the north. Then you have a spreading center we'll discuss and go all the way to Sangan Fault. Very long faults, and if it ruptures, it will also produce damaging earthquakes. And here is a seismic image of along somewhere here. This is your invisible bank, and we talked about continental. This is one of the volcanic arc, and this is your beautiful fault. And that fault is active. And there's other damage. This is particularly important if you're trying to do anything in Nicobar, which is, I heard the news that India is trying to set up a port next to 2-3 big faults. Be prepared and monitor it. What else? There was a swarm in 2005 after the 2004 earthquakes, and there have been several swarms in very close to northeast of Andaman and Nicobar Islands here. And those could be linked to the interaction between the 3 faults, which is coming from Sumatra fault here, West Andaman fault here, Andaman-Nicobar fault here, plus the volcanic arc. So it's a mess there. No surprise, there are a lot of earthquakes locally. And remember, even 4.5 to 5 magnitude earthquake near the port can be damning. So be prepared and get ready for that. What about, as we go, this is the discovery I discovered when I came as a Vajra chair, that they have found some manganese nodules on one of these ridges, which they call it vestigial rise. When I looked at the bathymetry and seismic image, which I had from my previous experience, I find that this is not part of vestigial rise, it's a volcanic island, but it's a compressional ridge, because we have sediments on that. So again, come back, even if you discover minerals, you need to know where they come from. What is the basics underneath? The message is that you need everything to explain what you observe at the surface. If you look at the surface, you will not know the cause and the basics and go and discover elsewhere. And as I said, further east, you have the Andaman-Nicobar fault, which is coming. This was Sumatra fault, that's the West Andaman fault, and you have pretty active seismic activity. And obviously, it's very complex. So understand this earthquake and tsunami, you need to map all the faults, monitor the seismicity and the structures and the depth. And obviously, the whole thing gets complicated by the presence of the volcanic arc. As you go further east, which is very exciting, you have a spreading center, which is called Andaman Sea Spreading Center, which is unsedimented in the south. We do not know the structure of this. It is the seismic image from here, and this is the seismic image from this side. And we have beautiful overlapping spreading center, which I'm not going into detail, but you could map the faults and the spreading center. So you just don't have the faults, you have spreading center, which is one of the biggest process on the plate tectonics. Most of the oceanic lithosphere, which is 2/3, formed by the spreading center. So you have in the back there, and if you are looking at the minerals, instead of going to Southwest Indian Ridge, you might want to look at something around this area as well. And I'll talk about what happens at sedimentary spreading centers in a minute. So this was the paper we published in Geology several years ago, where we could image the spreading centers, the magma chamber underneath, and interpreted the concept of how you have a spreading center formed during the sedimentation, which is coincidence. I put this seismic profile, Alcock rise in the north, and Sewell rise in the south, and this has broken up about 6 million years ago. So understanding how the margin starts, a rifting process. So you have an initiation of rifting in this area. So understanding how things has rifted will allow us to, like India separated from Seychelles about 60, 70 million years, understanding of that process too. So there's a lot going on in this area which requires understanding and thinking, both for basic science and other processes. So this is the kind of first time we discover a magma chamber under slow spreading ridge, not only very deep, but shallow. One is here, one is here. The main discovery is that what about, since we have a thick sediments, there's no lava flow. Everything is going in the sediments. So upper part of the crust is formed by sediment and the lava flow interaction, which is very exciting story. And once you have the melt, it goes to the sediments. What do? The melt are rich in minerals. Those minerals get filtered, reacted, and you could, the ore deposits. I'm sure on land you want to have ore deposits. Where they are formed, most of the gold, silver are initiated in this environment. So if you are looking for minerals on land, understanding what happens here can help you the process and look for the right place rather than just randomly as we do. As you go further east, this is a 180-kilometer long Andaman transform fault, which is also sedimented, which is very exciting for me. Now I can go and study the evolution of this transform faults, which separates one segment here with one northern segment, and how it evolves. And in terms of earthquakes, 180-kilometer fault will produce about 8.2 magnitude earthquake if it occurs. That's what happens further north in the Myanmar. So Andaman region full of exciting tectonics, geodynamic, and natural resource structures. As you go further east, as I said that you have Margui Basin here, this is your Sewell rise, you have thick sediments, there's a beautiful east basin, there's a fall there too, and obviously India has allocated for oil and gas exploration in this area. Let's see what they find. So the message is that to understand what happens oil and gas, you need to understand the geology and the tectonics. So what is the key results which I wanted to present to you? This is a general sketch. On this side, you have the 90s ridge. Bay of Bengal sediments are subducting, forming the 4-arc highs, but we do not understand how come we have ophiolites, which is 75 million years old. Presence of the 90s ridge could have a potential for subduction as well as the oil and gas processes. As I said, this is, I think there's a mistake here. Diligent fault is here. This is eastern margin fault. Both are active. So you have one fault here, one fault here, one fault here, and one fault here. So you have 4 faults around Andaman region on both sides of it. We discussed about the spreading center, which is geodynamically very interesting target and worth studying, the transform faults for in the north, and obviously spreading center, which really I work on. And For example, Alcock and seawall rises, we do not know when they were formed and why, and what they contain. Continental, volcanic, oceanic, the debate goes on. So the take-home message is that Andaman-Nicobar region hosts all the facets of plate tectonics, and one of the most fascinating targets you could look into a small area if you really want to do the basic science. Potential to produce devastating earthquakes as well as tsunamis, likely to have natural resources such as hydrocarbon or minerals. And obviously, it is a natural laboratory for both applied and fundamental research. And my message here, you said that you are starting. I have not seen much geophysics in the area, marine geology. So I will recommend India to really seriously take a program at a national level, not just one group, have a study of Andaman whole system as a globe, seismology, geology, marine geophysics, and so on and so forth. Just to kind of give a flavor of what I did other side, just across border of India. So I worked there for about 15 years, and this was the experiment funded by French government as well as Schlumberger, where I used big source, 10,000 cubic inch source, 12-kilometer long streamers. I'll not go in the details, and we did this survey. Our objective was to image the faults from here all the way to the surface and see how the tsunamis produce, the work I discussed to you. We also did the refraction survey along this profile to get the velocity structures. So the message is that you need the integrated seismic reflections as well as refraction if you want to understand the processes properly. This is the seismic image, first ever seismic image produced of the whole system down to about 40-kilometer depth. This is your sediments, top of the oceanic plate, moho, down to about 40 kilometers. And you need the velocity model, which suggests that these are accretionary sediments. You have oceanic crust subducting, continental crust on this side, and that's what could be happening. But as of today, I have not seen anything like this in Indian water. So it is essential, if you want to really study the future of earthquakes and tsunami and even the oil and gas, you need to have these images. So this was the paper published several years ago. We suggested that the main fault could have ruptured either that part or combination of two, which is a very exciting story published several years ago in Natural Geoscience. So that's kind of gives you what is need to be done. Can you think of bigger on an Indian scale? Over the last 20 years, since India started LCS program for EEZ, I have been trying to do a continental margin program, which is the good news is that DGH has compiled all the data set all over India and is releasing the data at a very nominal price to the academic community, both processed and unprocessed data set. So here is an opportunity for India to start the whole new program. Many people together, you can't compete because there's so much data set. If you're clever, you could process the data using advanced technique. So interestingly, India has all the three types of margin. On the west coast, you have volcanic margin, which is unique in India. On the east coast, we have passive margin, where you have a lot of oil and gas in this area, and Andaman, which is active margin. So you have all three types of margin in India, and you are sleeping, I would say. So wake up, please. What I was going to say, of course, the MCS data is very good, but they have a limited depth penetration, and we need the velocity model. So my advice is to do some obvious refraction survey to get the velocity and develop a geodynamic model. So my idea is to start a consortium, bottom up from the young scientists, which we are trying to set up at NIU and all the other colleagues in India at different institutions, and convince the big bosses to fund it. Or if you have money, maybe you could fund it and find a way to do it. It's not a lot of money to start with. You could start with a small money, but over long term, we need large amount of money. Every other countries have done it except here. So time has come, opportunity is there, please take the challenge. And it will be step change in understanding the margin and the geodynamic process in Indian context. With that, I would like to thank PGS who provided all the data set which I presented to you, ANRF who has paying my bill in India as a Vajra chair, and NIU has tried to give me a small office which I use time to time, and FIGA for inviting me. Thank you very much.
Thank you, Professor Singh. It was very interesting and very relevant to the FIGA as well as the institute where you are standing, because after your presentation, I have become more scary. I totally agree with you that much work is not done on the geophysics in terms of operational geophysics. In terms of earthquake and tsunamis, that is, I think, INCOIS is actually want to start a big national program to study geophysics, especially marine geophysics, and the aspect of tsunami, especially non-seismic tsunami. So, what you told, the pop-up structure, I think that is, should be taken more seriously, because the tsunami warning center all over the world now more focused towards seismic kind of tsunami, because non-seismic is also a possible because of the volcanism and the pop-up structure and the landslide and the sediment structure we have seen. This is where I think we have to have more focused national or international thing. We also working with IOC for this, especially Indian Ocean Tsunami Warning System, IOTWMS. So India holds big the positions in that. So before I'm going to my scientific question, can I ask somebody have the questions from the audience? Yes, sir. Sain sir, please.
First of all, congratulations. Very nice and educative talk to understand earthquake processes as well as energy scenario in Andaman-Nicobar zone. I have one, not question, actually want to know one understanding that a large earthquake can really uplift the sediments by normal faulting or thrust faulting. But the pop-up story, what you have brought out, that is very interesting. Is there any modeling by which we can understand that how much energy is required to make the pop-up, even for a small earthquake?
Yes, we have in the 2021 Hananto et al. Paper, we have modeled tsunami in Pagai Island. And so, yes, indeed, it can produce 16-meter high tsunami using this pop-up structure of magnitude 7.8. It's done. So please look at the paper, Hananto et al. EPSL 2021.
Satish, excellent as usual. Just I would like to supplement. You know, if you look at the gold deposits, they're all formed in Archean greenstone belts in all cratons. Now, actually, these greenstone belts are nothing but ancient subduction systems. What you are looking at is a modern analog of Archean or that time. That perspective also can be highlighted. So if we want to understand how our planet Earth has formed initial time, we need to look at Andaman because it has a beautiful natural lab. That's what it occurred to me when you said that. Okay? Great.
Yeah, that's what the message is. Yeah. Thank you.
Thank you, sir. Since we worked in Andaman-Nicobar post-tsunami, and we have done the passive tomography, we found the sediments there, but we found none of the earthquake occurred in the sediments. And we explained that the sediments is ductile and it has no capability to be a brittle to be pop-up or can absorb all the seismic energy generated by the earthquake beneath the sediment thickness. Similar work has been done in the Bengal fan, in the Dauki fault below in the northeast India. We also found the similar thing that there is none of the earthquake occurred in the sediment belts, and it was because of the ductility of the sediment. So can you explain that what physics of that the seismic energy will be not absorbed, rather it will be amplified in the case of the Andaman tsunami? Thank you, sir.
Yes, so just to repeat what he's saying, that sediments are ductile and they don't break, depending upon the force you are using. So that was the concept. I go back and I basically challenge the old dogma that sediments are soft and you don't have rupture propagating to the subduction front. And that led to, over the last 40 years, saying that you will never have a rupture propagating to subduction front. So what happens, the physics is simple. Depending upon the force you are using, it is not ductile, it's soft, it's hard enough depending upon the speed you are moving it. So when the rupture is moving, it can break, just a plastic. Plastic is ductile, but it breaks as well. So depending upon the strength, so depending upon the rheology and the force you are bringing, it will break. And we have shown that in that paper that, yeah, it does break. Numerically modeling. There was a paper by Cubas et al., Geology 2016, I think. We published that paper. Coming back to the pop-up structures, again the same story. You see the faults everywhere. They are not ductile. They are active faults. Did you see that? They are all over the place. You don't have earthquakes in sediments. Doesn't mean that they don't break. Earthquakes occurs deeper. All you are seeing is the surface expression of those faults. So what you see in your earthquake location, source initiation, not the where they come. All the images I showed you, and thousands of images, you have faults everywhere. And they are broken. They are in sediments. Even in the passive, basin, you have orthogonal faults. They are faults. They break in the sediment. So the concept that they're ductile is old, not anymore. Sediments are as active. They can produce large earthquakes depending upon the movement. That answers your question?
Yeah. It's a wonderful presentation. Systematically, you made from west to east what is happening in the Andaman subduction zone. But, I have two questions. One is, in your opinion, when is the Andaman Basin really opened? Is it 6 million years or 21 million years? Or
Andaman, the current basin, Andaman Sea Spreading Center is between 4.5 to 6, depending upon Raju et al. Or other one.
Yeah.
That's what I say. How old are Alcock Seawell rises? We do not know.
Okay.
So those are they volcanics or they are what else? We don't know.
Okay.
There are some volcanism. So basically, we do not know. Basically, we know that there is something. East Basin was active 16 to 22 million years ago. Before that, we do not know. Yeah. So the message is that our knowledge, this is the image I produce you.
Because the Andaman abduction is believed to be during Oligocene.
Yeah, but Andaman spreading has been going on for a long period.
Yeah. Okay.
So it's not new. Ophiolites, 95 million years, they must have, if they are dated correctly, let's me be honest, I have no idea, I trust the numbers. So there was some continental material there. Subduction was all along.
Fine.
So again, we need to know when.
What exactly is that?
Yeah.
So coming to my second question, is that you identified pop-up structure within the sediments that can generate tsunami even for moderately large earthquake. But this is a partially subduction zone, oblique subduction zone. But there are many other subduction zones elsewhere which are normal, where coupling can be much more greater than in a oblique subduction zone, and then pop-up structures could be there also. Why there is not many tsunamis occurrence even for 6.5 earthquakes elsewhere also?
There are everywhere a tsunami. You have I told you Pagai. Similarly with 1907 tsunami earthquake.
Really?
Java twice, I think, 2006 and 1990.
Elsewhere in the other subduction zones also?
Yeah, I'm coming to. Go back to Alaska. There is a tsunami earthquake in Alaska. Peru earthquake, I can't remember, 1994. All of them are linked to now, since we suggested, linked to pop-up structure.
Okay.
So the
Nice.
Kanamori's idea of 1981-82, the tsunami earthquakes occur due to process of slowing down, is no more valid. It's the pop-up structures produce tsunami. The word tsunami earthquake you might have heard in your literature are not due to what Kanamori proposed in 1982. It's the pop-up structures are responsible for those tsunamis.
Yeah, so if the questions are over, I have one question that is mainly operationally related to tsunami warning. Sir, you know that we have a Palau tsunami where we failed, almost all tsunami warning systems failed because it was a low magnitude earthquake, but still it's a landslide, it happens. So how much is the possibility of having a tsunami in this area by the landslides or volcanisms, according to your study?
Well, again, my dear friend, you need to do the bathymetry. As of today, to my understanding, that India does not have the bathymetry of that region. So that's very reason, at least you go and do the bathymetry so that you could identify those landslides. We had no idea. South of India-Indonesia border, all the way to Java is covered by bathymetry. North of India-Indonesia border, you can go and ask your colleagues, what have you done? So you need the image. Okay. At the moment, we do not have a bathymetric image. And then once you have, then you can study when it happens, what was the size of tsunami, you can model that. At the moment, you are blind. Okay. Yeah, and hence my insistence.
Nicobar Basin, we have some multi-beam bathymetry.
Yes. Small amount. Yeah, small amount. Again, it's a patchwork. I saw it. It's all patchwork. India is a great country, as you describe. You can't do the patchwork. Yeah. You need the really great, large-scale bathymetric, geophysical survey, systematic way. Allow young scientists to think about it rather than just patchwork. I see the patchwork, and everyone has their own bathymetry in their pocket. You can't even see someone else's bathymetry. And that's terrible because to understand, you need the whole thing in front of you.
Yeah, so, that's correct, sir. If you want to have the modeling, tsunami modeling, this is very important for us. I think
just want to add, as part of this Ministry of Earth Sciences project actually to map the entire exclusive economic zone of India actually. So there is a large amount of data. Now that mapping process is underway. We have data below 500-meter bathymetry as of now for the entire EZ, which is at a very high resolution multi-beam bathymetry. So that's being passed, what you call stitched together now, and the maps are being created in collaboration with the Geological Survey of India Marine Wing. So at least for the EZ part, there would be soon very high resolution data, but not the entire basin what you would be like to have.
Yeah, thank you I tried to look at those data set, and I was not allowed to see. That's the first remark. Second remark I'll make, and I want to be very clear. For the last 20 years, when you started your EEZ program, every directors of NCOPR and secretary said that those data will be released to you tomorrow. We are 20 years down on the road. You are still telling me that it will be released soon. Okay, I remember coming to NCPR 217. That time director said that you will be released soon. Salek Nair secretary when I was there. It will be released soon. So please make that soon real sooner or later. Thank you.
Yeah, thank you, sir. Sir, and one more question I have. We have, again, I am telling an operational tsunami warning system. So you are seeing the observation systems, strong motion accelerometer or GNSS. So you have any suggestions for the real-time detection of earthquakes, that is mainly tsunami-genic earthquake? You want to make a dense network. Which area you suggest?
Miss, again, we need to know where to look for. At the moment, we are blind. So my advice is to study more, have at least bathymetry and seismic network. If you are going to have a port in Nicobar, have a set of OBSs. Someone described there is a cable between India and Andaman. What is the cost of that? How much you spend in Andaman-Nicobar understanding it? So you take a big project, the study is not done. So to do that, you do need, the first thing is the studying of it, and then can say, okay, do monitoring properly. Then we can address your question.
Sure. Yeah. Sir, actually within 2 minutes, there's a Government of India instructions to raise everybody for the Vande Mataram. So 10 o'clock, yeah.
Now, I mean, I recall it and it looks fascinating. Fantastic.
Thank you.
NGLI, and they may be processing. It's 5 years down the line it was done.
Any idea about spreading rate across
Mataram, Vande Mataram, Sujala, Sufala, Malaya Jashitala, Sasya Syamala Mataram, Vande Mataram. Josra pulakitaya gini, pullakusumita drumadala shobhini, suhasini, sumadhura bhashini, sukhadam varadam mataram, vande mataram, vande mataram.
The spreading rate is about 37 millimeters per year. It's a slow spreading.
Sir, also I can request Dr. V.M. Tiwari, sir, on stage to give a memento to our chairperson, Dr. Balakrishan Nair. Dr. V.M. Tiwari, sir. So thank you, sir. So now we have a breaking session, session 3 and session 4. Session 3, energy resources, which happens right here. And session 4 will be happen in the e-classroom. Team can move forward to the e-classroom who wants to go the session 4, marine geodynamics. And rest can stay back here to have a session of energy resource, session 3 here.
And services daily basis, 24/7 basis. Please visit it. Our people will facilitate that one. Thank you.